Okay, so now that you know how to factor so that you can find where the x-intercepts are, and you have the different ways of solving, we can go back to graphing, because now we know a little bit more about the graph. So what we're going to do is call, instead of just a regular parabola, we're going to be graphing what's called inequalities. So in this case, we might have a dotted with, let's say, shaded above or shaded below. Okay, so that's what we're looking for. All right, so we need some notes. On page 72 in your workbook, there are a couple different ways, and I do this different than probably other places that you've seen where they test. I only use step 1. So once you graph the parabola, if it is a less than or greater than only, you're going to use a dashed line, or a dashed curve, I guess, a dashed parabola. If it is with an equal to on it, like this, then you're going to use a solid parabola. Now, in this case of, in this case where it's a less than, you're going to shade below the parabola, and in the case that it's a greater than, you're going to shade above the parabola. And so what we're trying to do by the end of this section is to have one parabola shaded one way, another parabola on the same graph, and we're going to see where they intersect. Okay? And that's what we're trying to get to. So here is your notes that I kind of just gave you. The dashed line is for there. The solid line is when the equal to is on it. Okay, so we got a couple different ways that could look. This will be the dashed line, where we have less than or greater than, and then this would be your solid, where it would be less than or equal to and greater than or equal to. Okay, and on page 73, I just want you to practice matching A, B, C, and D with 1, 2, 3, and 4 off of what you just learned. So feel free to pause and then come back and play it when you have your answers. Number 1 is dashed. These two graphs are the same. 1 and 2 have the same graph, so it's going to be either A or C. This one is dotted, which they should both be dotted, but this A is less than, shaded below the graph, which is going to be 1, and then shaded above the graph is going to be 2, which is that greater than symbol. 3 and 4 are B and D because they have the equal to on them. It's the same graph, so I don't really have to worry about that right now. And then this is going to be less than, which means shaded below the parabola. So 4 would be B, and then 3 would be D. Okay, now we're going to go through some examples, and I'm going to go ahead and warn you, I'm going to do this fast because you already know how to graph. So I'm going to leave some steps out. We're more concerned with the dashed, solid, and shading than we are graphing. You already know how to do that. We spent lots of time on it. So, so what I'm going to do is just kind of give you notes. Feel free to pause and catch up as you need to. All right, so in number 5, we're going to use just a regular standard X and Y axis. We know that this is a parabola going up 2. So I'm going to go ahead and take my vertex at up 2. And remember, I always want you to plug in a point. So if I plug in 1 into this function, I'm going to get out 3, because that would be 1 squared plus 2, which would be 3. Again, you just need a parabola. Once I have that parabola, I see this symbol, which tells me it's going to be dotted, and it says y less than, which means I'm going to shade below. So this is kind of what your graph would look like. Okay. All right, and the next one, this is vertex form. I know it's going to face down, and the vertex is going to be at -4, -1. I certainly hope you didn't forget that yet. So let's put our graph in again. We're going to be at -1, 2, 3, 4, -1. I need to find a point that's close to it and plug it in. So I'm going to plug in -3. So when I do that, because I do need that extra piece, that'll be -1 minus 1, which is -2. So I'm going to come down here and make my points at -2. So here's my parabola. Before I draw it in, I need to notice that it's going to be a solid line. facing down, or I say line, but I mean curve, and it will be y greater than that. So the cool thing, when you're working in class, you'll be able to use your highlighters in a little bit, or something a little thicker would be cool to see. So that's kind of what your graph would look like. So that means every single point that's up here in this shaded area, any point that I choose, there's infinitely many of them, is going to be a solution for this equation. So when I plug in the x, I plug in the y is always going to be greater than or equal to that, side of the function. Okay, so let's do another one pretty quickly. This is in what we call standard form. So remember, in standard form, you have to use negative b over 2a. So that would be negative 4 over 2 times 4. That would be negative 4 over 8, which would be negative 1/2. So I'm going to start this vertex at negative 1/2, and then I have to plug it into the function. So I'm going to pause the video and find that on my calculator. Okay, so it looks like that gives me 0 when I plug it in, which is kind of cool because that tells me I've also found the zeros, or the solutions of the function. So what I'm going to graph is the point negative 0.5 and 0. All right, now I'm going to plug in 0. When I plug in 0 into the function, I get out 1. That's going to give me these 2 points. Again, if you need to back up and watch that again, it's just a reminder of how we graph. Now this is going to be dotted and shaded. If it's less than, it's going to be shaded below. So that's going to look like this. And again, all that means is that I can pick any point in this shading, and it will always work for that formula. It will be shaded above. Now watch what happens here. What I'm looking for my solution is where I see blue and green. This is where I would like for you to try one on your own, and just try it right there on your workbook. You're welcome to use colors, or you can just use pencil, it doesn't matter. But pause the video, try it, and then come back and check. Okay, so what we're going to do is graph this one first, and this one should be pretty easy because it's just going to be an upside down parabola. So I know the vertex is at 0, 0, and if I plug in 1, I would get out negative 1. Okay, so far so good. That's going to be a solid curve, and it says y less than, which means we're going to shade below the graph. Okay, and now in green, we're going to do this one. I already know that I'm going to be moving up 3, so I'm going to go ahead and do 1, 2, 3 for my vertex. If I plug in 1, I actually, in this case, will get out 0. So it should be here and here, and that's going to be a dotted curve. Okay, now watch what happens here. This one is greater than, so that means everything out here is part of your solution, and that's all wonderful, but what I'm concerned with is where they actually meet, where they cross. So if you'll notice in here in this very small area, all the points that fall in this section is part of my solution. Okay, so the green doesn't matter, the blue doesn't matter, it's the fully shaded part, which is where they intersect.